This short talk serves as an introduction to the units, conventions, and notation that you should use in the course of this class. Unless stated otherwise, for all calculations, you should use SI units. That means utilizing meters, seconds, and kilograms for all calculations. Sometimes you may see such things as meters and kilograms given in slightly different forms. You may see centimeters, you may see grams, and it's your responsibility to make sure that you convert to the correct units. Many scientific constants are normalized to the meter and the kilogram, and as such you have to make sure you're in the correct regime to make sure your calculation is not out by some factor of 10. As such, you can often shift the decimal place as needed. So the micron, which is a millionth of a meter, is 1 times 10 to the minus 6 meters, or 0.000001. Time tends to be a little more normal and the same in all different types of unit measurement. So 86,400 seconds is 1,440 minutes or 24 hours. 1,000 grams is a kilogram. So when we're dealing with mass, make sure if you are looking at, say, the acceleration due to gravity, that you're utilizing the kilogram. As such, you may see some of these common prefixes. If you see the centimeter, that's 100th of a meter, 10 to the minus 2. The millimeter, 1/1000th, which means if you were to put this in scientific or engineering notation, would be 10 to the negative 3, micro is a millionth, nano a billionth. This notation makes it a lot easier to do calculations and to grade your work. Calculating a large number or a very small number and counting a lot of zeros can often result in mistakes when entering the numbers into your calculator, but also when simply reading them. On the larger end of the scale, we have units such as the kilo, so kilometers, kilograms. This is 1,000 or 10 to the 3, mega, a million, giga, a billion, 10 to the 6, 10 to the 9, respectively. So make sure you're familiar with this type of notation. 10 to the 2 is essentially 10 times 10, which is 100. 10 to the 3, 10 by 10 by 10 is 1,000. And 10 to the negative 2 is 1/100th, 0.01. So this would be something like the centimeter. If you have your scientific calculator handy, you can always use the ENG button to change the notation of your numbers. But please be careful. Sometimes if you hit this button and you have, say, 6 zeros, you can actually get 10 times 10 to the 5 produced by your calculator instead of 1 times 10 to the 6. This will help if you're looking at a large number and want to quantify it without too much hassle, but please be careful when you're using your calculator, and it's your responsibility to understand how it operates and what answers it's giving to you. When we talk about the accuracy of a measurement, what we're really talking about is how accurately can we quote a value? How reliable is that number? Well, if we look at physics, there's a range of reliabilities. If we're talking about the radius of a hydrogen atom, this is about 5 times 10 to the minus 11 meters. That's extremely small. We know this value to plus or minus 1 times 10 to the minus 11 meters. That error is actually on the order of the value itself. This is due to a number of effects involving quantum physics and uncertainty, but still, this is an enormous error in the radius of the hydrogen atom. This is a particular object of which this room is actually full of them. There are hydrogen atoms all around us, yet we don't know its radius to any great accuracy. The distance to Pluto, on the other hand, which is on the other side of the solar system, is 6 times 10 to the 12 meters. We know the accuracy of this distance to 1 times 10 to the 3 meters. So we actually can constrain the distance to Pluto much more accurately than we can a room full of hydrogen atoms. Where most people make a mistake involves significant figures. If you were to take the value of 3.15 and multiply this by 3.4256 and then quote whatever your calculator gave, your calculator would give you 10.79064. This would be the wrong number to quote. Here you're going to 4 decimal places. Here you're going to 2. You can only go to the minimum number of decimal places. So, if we were to round this, we would say this was 10.79. This would be the answer we would quote. This is especially important when you're looking at solving multiple choice questions online. Make sure that the answer has not been rounded or has been rounded when you decide to make your selection. As I said, in terms of measurements, we're going to employ the SI system of measurement. Some people don't usually use that in their everyday life. In that particular case, I would suggest that you familiarize yourself with the conversions. Sometimes, especially when we quote such values as meters per second, people tend to think in miles per hour and can often quote enormous values that they do not realize are physically unacceptable. Make sure you're quoting physically reasonable values at all times, and if you're unsure, convert them into a unit you're more comfortable with, at least at the beginning of the course, just to make sure you're not making a statement that's scientifically wrong. This is also true of mass when we're talking about the metric system versus pounds and ounces. Make sure that you're making your calculations correctly if you need to by converting them into a unit you're familiar with. You do not need to employ those units in the calculation, always use kilograms in your calculations, but if you want to know what's going on and you want to put things in context of values you understand, please go ahead and convert by all means. But all values in this class will be in meters, kilograms, and usually seconds. Mentioning seconds, we wanted to discuss time. Time is the same in nearly every system of unit measurement, and it's based on the orbital period of the Earth. The Earth goes around the Sun once a year, and it rotates on its axis once a day. So 1 year, 365.25 days, which is 52.177 weeks, or 8,766 hours, or 525,960 minutes, or this many seconds. Got a bit lazy there. We will have to employ trigonometry in this class, and occasionally there might be a slightly more complicated trig function that you will have to perform, but generally most of the problems we will solve can be solved with the 3 basic trigonometric identities of sine, cosine, and tangent. The trigonometry in this course is not overly complicated. And if you find yourself doing very, very complicated trig and doing multiple pages of trigonometry, you're probably doing the problem wrong. And it's a good idea to return to the original problem and look at it again and try to decide what you're doing wrong. This is a physics class, which means we are applying mathematics. There may sometimes be mathematics that's a little more complicated than this, but if you're going for a very, very complicated solution, you probably have it wrong. Don't be afraid to start from the beginning again and try to simplify your solution. The smartest people are the people who come up with simple solutions to complicated problems. So you should be confident in using right-angled triangles, the law of sines, the law of cosines. I would suggest you look these up if you're not familiar with them, or speak to me. If your trigonometry, as I said, is very complicated, you're probably doing the problem wrong and need to revisit your approach. There are formulae that you will need to rearrange in this course. Typically, these are relatively basic, such as f equals ma. If we wanted to rearrange this to find acceleration, it's three variables. A equals f over m. We do see more complicated formulae, such as the force due to gravity here of gmm over r squared. There is an electrical analog as well of F equals k q1 q2 over r squared. So be prepared to rearrange formulae such as these, either small three variable formulae or slightly more complicated versions. In terms of mathematics, you should be familiar with performing powers both with and without a calculator. 2 squared is 4, 2 cubed is 8. Performing roots the opposite way here, so the square root of 2 is 1.41 and the cube root of 2 is 1.26. You may occasionally see a cube root. It's your responsibility to know how to do these things on your calculator and find the appropriate buttons. People have different versions of calculators, and I'm not entirely familiar with which calculator you have. So this is down to you. Cell phones cannot be used in place of a calculator during exams or in class tests. Occasionally, we might see logarithmic relationships, either natural logs to the base e or log to the base 10. So be familiar with how to perform these on your calculator and how to translate logarithmic graphs where possible. You may also see Greek lettering. So Greek letters are often used to represent specific values. Alpha, beta, gamma, these are often constants. You can see these representing types of radioactive decay, although this class does not delve into that. Delta usually represents some change in a value, whereas lambda is usually a wavelength, sometimes a constant. Here we have an epsilon, which is a summation. Pi, which you should be familiar with, being 3.142, which is the ratio of the circumference to the diameter, is definitely a useful value to know. Theta and phi, where applicable, usually denote angles in a problem. Finally, being originally from Britain, of course, there is a slight problem involving Z, as you would say it, or Z. Not that this is a problem, but I'm making you aware of it. Now, I tend to say Z. Occasionally in class, I might try to use Z, which I think sounds kind of like C. So I will probably end up deferring to using Z. If I say Z, what I mean is Z. Unfortunately, because this is hardwired into my brain and Big Bird did not infest my soul, you may have to live with this slight eccentricity. But having been made aware, you should be able to deal with it.